Hello everyone, and welcome to Chemistry is Everywhere, our YouTube channel where we talk about a wide range of chemistry topics. My name is Tom van Oefel, and today we will be talking about radiocarbon dating, also known as carbon-14 dating.
There are 3 isotopes of carbon found in nature: carbon-12 with 6 protons and 6 neutrons, carbon-13 with 6 protons and 7 neutrons, and carbon-14 with 6 protons and 8 neutrons, so an atomic mass of 14. Carbon-12 forms around 99% and carbon-13 around 1%, and both are stable isotopes. Carbon-14 accounts for less than 1 ppb, so less than 1 part per billion. Carbon-14 is radioactive and will decay into nitrogen-14. The rate of decay is constant, so it can be used as clock to determining the age of organic materials, such as fuels. Carbon-14 atoms are continuously produced in the upper atmosphere. High-energy cosmic rays collide with nitrogen atoms, which absorb a proton and emit a neutron, transforming it into carbon-14, and rapidly combine with atmospheric oxygen to form CO2, carbon dioxide. The carbon-14 atoms then enter the organic carbon cycle through photosynthesis, and their inorganic carbon pool in the oceans, lakes, and rivers. When organic matter dies, it no longer exchanges CO2 with its surroundings, and the radioactive decay clock starts ticking. Carbon-14 decays by emitting an electron, a beta particle, which converts a neutron to a proton, turning it back into its original nitrogen form. Carbon-14 decays at a constant rate, with a half-life of 5,730 years. The half-life is the time it takes for an amount of radioactive isotope to decay to half of its original value. There are 2 main methods for measuring the carbon-14 content of samples. Radiometric counting involves counting beta particles emitted during carbon-14 decay. The sample in a liquid form is mixed with a scintillation standard that emits light flashes when struck by beta particles. A scintillation counter measures the light flashes. Accelerator mass spectrometry, or AMS, is an advanced and accurate method for measuring carbon-14. Unlike counting decay events, AMS directly measures the ratio of carbon-12, 13, and 14 atoms. The sample is ionized and accelerated in a magnetic field, separating isotopes based on mass. AMS requires much smaller sample sizes but sophisticated, expensive equipment. Renewable fuels have the same carbon-14 levels as the surrounding atmosphere. Fossil fuels, on the other hand, do not contain any residual carbon-14 isotopes. These all have decayed during the millions of years they were buried under thick layers of sediment. This makes radiocarbon dating a useful tool for certification of renewable fuels.
Now you know. Thanks for watching. For any questions, comments, suggestions for other topics, feel free to contact us. I hope to see you again. Stay safe.